Example of taking a derivative using the power rule. A lot of notation here and a lot of ideas going on. We want to start off with the idea that this already says that a derivative has been taken. And so we want to go to the next derivative, to the second derivative. And that notation is written as d squared y over dx squared. Notice that we have fractions as exponents, so we've got a lot of different things going on here. As I start my derivative, I'm going to take this power times the term. So 2/3 times 9 should produce 6x, and then I subtract 1 from the 2/3. I drop it down by 1 unit, so 2/3 minus 1 would go to negative 1/3. And that's what you see here where I said 6x to negative 1/3. In a similar way, as I go to the second term, 2/5 times negative 1/2, the 2's would cancel out, and that would leave me with a negative 1/5. X to the negative 3/5. The negative 3/5 comes from me going 2/5 minus 1. 2/5 minus 1 is negative 3/5. And then the last two terms are fairly easy to take a derivative of. The derivative of 3x is simply 3. The derivative of a constant drops out at 0. And so I look at this derivative, write it like this. We don't like those negative exponents, so of course I'm going to need to drop the x component down as a denominator. As I drop it down, I will write it as 6 over x to the 1/3 minus 1 over 5. The 5 was already down there. And this x to the negative 3/5 comes down as x to the positive 3/5 plus 3. And for the most part, I would leave it there unless perhaps you had a question where they're looking for an equivalent statement. But for that, I would leave it just like it is. I wouldn't change it. And there's your example. How to go from a first derivative to a second derivative. Nothing changes, just the notation.